Now let's assume that you are being given the vertices of a triangle. Let's say the vertices are given as a triangle ABC. Let's say a point A is having the coordinates 1, 2, 0, and let's say a vertex B we have 0, 0, 0, and the vertex C we have -2, and let's say 1, 0. And now let's say it is being claimed that this is the right angled triangle. How can you be able to determine if it is the right angled triangle or not using the vectors? How can we be able to determine, rather how can you be able to determine if the triangle corresponding to these actually vertices it's a right angled triangle or not using the vectors? So now in this case, first thing you should have to visualize or just have to come up with a sketch of whichever the triangle of your interest, and much as you don't know whether the triangle is right angled triangle or not, but just come up with any kind of a triangle. It will give you the picture on how you can map it forward. And let me just have to use this. This is just my simple triangle, and I'll say this is the triangle A, B, C. I'll just have to say it in that way. So in this case, what I want to do is just to calculate what is vector AB. I'll have vector AB, and I'll need vector BC, and I also need vector AC. So this one will really help me to map forward and what is to be done. Just have to come up with any sketch that you may suggest that will help you to have an overview or to have the picture view about the triangle itself, just in triangle, much as you don't know whether it is right angled triangle or not. So we're going to use the Graham vectors to find these actual vectors, of which I understand everyone knows how to determine or find the Graham vectors. So what is vector AB? Now the vector AB will be given as 0, -1, we'll have it as -1, -2, and a 0. And what is the vector BC? We'll have it as -2 minus 0, we have -2. And the 1 minus 0, we have it as 1, and a 0 here. And we need to have what is the vector AC there, and that corresponds to have it as -2 minus 1, that is -3, and 1 minus 2, that is -1, and also 0 here. And then next we should have to pair up these vectors and to see if we have any two vectors and that are perpendicular. So in this case, we'll have the dot product between a vector AB and let's say a vector BC. We'll have that, and also the dot product between, let's say, vector AB and vector, I should say, between a vector BC as well as the vector AC. We'll have that. So have it as the dot product between the vector BC and also the vector AC. This will be the way to. And also the dot product between, that is between AB and also BC. That is enough. That is basically enough. Of course, we can also have the dot product between a vector AB as well. That is very important as well. Between vector AB and the vector AC. This is also important. Then we'll have those dot products. Let's see how it will work. Let's have the dot product between vector AB as well as the BC. What would that be like? So have negative 2 times negative, actually say negative 1 times negative 2, we have it as a positive 1. That is a positive 1. Then negative 2 times positive 1, we have it as negative 2. And the 0 times 0, we have it as 0. So that will correspond to have it as a negative. That is negative 1. That is the dot product between those two vectors. And let's do it again. We have, should be negative 2 times, I should say negative 1 times, I should say negative 1 times negative 2. That is positive 1. And negative 2 times 1, and that is negative 2. And 0 actually 8 times 0, we have it as 0. So that is a stromal. Yes, that should be negative 1. But should we have the dot product between any two of any vectors here to be given as 0? It means the angle between those two vectors is 90 degrees, hence it is right angled triangle. Let's just do more proceed that one. Now the dot product between the vector BC as well as the AC. What would you say? Negative 2 times negative 3. That is positive 6. And positive 1 times negative 1, we have it as a negative 1. And the 0 times 0, we have it as 0. And this is giving us 5. So to do more, we need to go for another vector, another dot product of these two vectors. Now vector AB dot vector AC. What did you say? You know, negative 1 times negative 3, that is a positive 3. And now negative 2 times negative 1, we have it as a positive 2. And now we have 0 times 0, that is 0, plus 0. So that is also giving us 5. So as you can see, there is no vector whose dot product is 0. Hence these vertices does not correspond to have, or does not correspond to the right angled triangle. Now how about if we have this case? Let's say we have the triangle B with our vertices given us, let's say 2, 0, 1, and let's say we have 0, 1, 2, and let's say we have, you know, negative 0.5, and let's say 1.5, and the shape is out here. Now what did you say? Principle remains the same. Or else, without coming up with a sketch, you can also just have to do this as well. Just have to you need to have an insight of whatever the particular triangle you can have. So which means all we need is to have vector PQ. You need to have also the vector that should be QR, and also you need to have the vector PR. That is, and from there, these are the column vectors you should know. So what is a vector PQ? Now that corresponds to have it as -2, +1, and also +1 as well. And how about the vector QR? It should be given as -0.5 and comma. What is 1.5 minus 1? We have 0.5, and also we have -2 here. And how about the vector PR? Now we'll have it as a -2.5 and comma should be 1.5, and that should be -1 here. So those are the vector columns, actually column you should have to understand, and of which I guess you know how to calculate these column vectors. And now we should have to determine what we call the dot product of the pairs of the vectors. So vector PQ dot vector QR. What did you say? And vector QR dot vector PR dot vector PR, and also vector PQ and dot vector PR dot vector PR. You should have that, and you should have to see which one was dot product to be given as cell. Then what it means is that that particular triangle is around the triangle, and you don't need to proceed. Wherever you have the dot product as cell, it means you stop there and conclude that the actual triangle is around the triangle, since the dot product between the two vectors L, it corresponds that those two vectors are orthogonal vectors or perpendicular. And from the fact that the along the triangle, one of its internal angles is 90 degrees. But let me just have to proceed this one for you. In the vector PQ dot vector QR, PQQR, right? It means we have -2 times -0.5. So -2 times -0.5, and that is we have it as a +1. We have it as a +1, and we have 1 times 0.5. That is plus. So what is 1 times 0.5? It is the same as 0.5. That is 0.5. And we should have also 1 times -2, and that is -2. So if you sum up here, what would be that? Then you realize that we have 1 minus 2, that is -2, 1 minus -2, that is -1, and a plus 0.5. That would be -0.5. -0.5. It means we should still have to go down. And let's try the other ones. So what did you say? Actually vector QR dot vector PR. Actually QR versus PR. So we have negative 0.5, negative 0.5, and the times should be negative 2.5. That is giving us 1.5. Let me take this one now. And that is 1.25. And then we have 0.5 times 1.5. So 0.5 times 1.5, that is plus 0.75. And then we'll have a 2 times, I should say negative 2 times negative 1. That is giving us the positive 2. So let's think of adding those. Now we have 1.25, and plus 0.75, and the plus 2. That will be giving us, and that should be 4. Then we should also go down as well. And let's check it out for the another one. Although I'm suspecting something about those two vectors, I'm thinking that there has to be some sort of errors that arised between these two vectors during the calculations. Anyway, you can also prove on your own about the calculations that I've done here. And now, what is the dot product between these two final vectors? So we have vector PQ dot vector PR. So PQ PR, that is, so we have negative 2 times negative 2.5. That is, we have it as a 5, of course. Then we have 1 times 1.5. We have it as 1.5. Then we have 1 times negative 1. That is giving us the negative 1. And you realize that we'll have 5 plus 1.5 and that minus 1. That is giving us 5.5. So it means these vertices does not correspond to the right angle triangle. It means this is not right angle triangle. And let's try the other ones as well. Now you should have to try this at your own time and check if the vertices corresponds to right angle triangle or not, and appreciate as well. Let's say we have the triangle SPQ, where is holds the coordinates of 2, negative 7, and comma 3, and P is having the coordinates negative 1, 5, and 8, and Q having the coordinates given as 4, 6, and comma negative 1. And I also try to have this a triangle MN, where M having the coordinates of, let's say, negative 3, 0, 0. And the coordinate of N we have should be 0, 0, 0. And are all with coordinates given as 1, 2, 3. So determine if this coordinate, actually if this vertices corresponds to right angle triangle or not.